Okay, here's an example of Hess's law where we're using the first method when you're given a series of equations and you have to find a net equation. So this is my net equation that I'm trying to obtain, and I want to know what's delta H for this reaction. And I can find it if I rearrange these equations. I can add up the sum of the delta H values at the end, and that's going to give me my answer in kilojoules. But we have to manipulate these equations first before we can begin to start eliminating. So here's the net equation that I'm trying to figure out. This is the equation for the smelting of iron. Here's the three that I have to work with. Try to ignore if there's oxygens or waters. Usually you can ignore those. In this case, there isn't. CO2 and CO, I'm going to do those last, okay, because the similar way that with oxygen and water, they tend to kind of cancel out and work out at the end. So we'll focus on the other reactants first. In my net reaction, I need one iron 3 oxide, and I need it to be on the reactant side of the arrow. So I need it to be on the left side. So I want to scan my three equations. Where do I see iron 3 oxide? Well, I see it right here, and yes, it's on the correct side of the arrow. The issue is, though, in my net equation, I only want one, and here I have three. So a way around that is to divide this whole equation by 3. So everything in that equation we're going to divide by 3. That'll give me 1 iron 3 oxide. And here I only have 1, so divide by 3 is going to give me 1/3 carbon monoxide. Try to keep your arrows all lined up. This will give me 2/3 iron 4 oxides, and then we're going to have 1/3 CO2. My delta H value also has to be divided by 3. So negative 47.2 divided by 3 is going to give me a new delta H of negative 15.73 kilojoules. The next thing I can look for, so I'm going to do the carbon monoxides and the carbon dioxides last, but here I know that I have to have two solid irons and I need them to be on the product side of the reaction. So I need them to be on the right side of the arrow. In equation 3, I do see one of those solid irons. Here I need 2, here I only have 1. So for this one, we're going to multiply everything by 2. So we're going to double everything. So I'm going to get 2 iron oxides plus 2 carbon monoxides and 2 solid iron plus 2 carbon dioxide. My delta H, I also have to double, so it's going to give me negative 22. Now, the third one, okay, this equation is rather tricky actually, because we've got all these carbon monoxides and all these CO2s, and we know they have to add up to the end to give us 3. A trick for this one is if you can't figure out how to add up the CO2s or the COs, one thing I would pay attention to is that I see this Fe3O4 as part of equation 1, and that is not part of my net reaction. So I know I need to cancel that out eventually. So we're going to do that. Here I have 2/3 of them. I have to have the same number on both sides of the arrow to cancel it out. In this equation, I have 1 of them. So I'm going to times this by 2/3. And you'll see at the end, I promise it'll all work out. So we get 2/3 of these guys that I want to cancel. And then we'll have 2/3 carbon monoxide. 2/3 times 3 will just give me 2 iron oxides, which I also need to cancel at the end. And 2/3 CO2. 19.4 times 2 over 3 is going to give me positive, in this case it's positive, so we get positive 12.93 kilojoules. I didn't have to reverse any of my equations, so if we flip them, we change the sign of delta H, but I didn't have to do that for any of mine, so we can leave it as is. Now we can start canceling stuff out. So take a look at what appears on both sides and cross it out. Here I've got 2/3 of Fe3O4 on the right side, and here I've got 2/3 Fe3O4 on the left side, so I can get rid of that. Anything else that appears on both sides, well, here I've got 2 of these guys and 2 of these guys, FeO. Nothing else will cancel, so now I take the sum of everything. So I've got 1 of these guys, which is good, I've got that here. I need this to add up to 3 carbon monoxide, so I've got 1/3 plus 2 plus 2/3. If we add that up, we get 3. This side, I have 2 solid irons, and again, I need 3 CO2, so I have 1 over, that should be a 3, sorry, 1 over 3 plus 2 over 3, that also adds up to 3. So we've got our net reaction. Now all we have to do is total up these delta H values. So negative 15.73 plus negative 22 plus positive 12.93 is going to give me negative 24.8 kilojoules. If it asks me to find the molar enthalpy of one of my reactants, like let's say it asks for the molar enthalpy of carbon monoxide, then I would take the enthalpy of my reaction, negative 24.8 kilojoules, and I would divide that by the number of moles in the reaction. So 3 moles of CO, and this will give me my units in kilojoules per mole. So we're going to get about 8 kilojoules per mole. 24.8 divided by 3 gives me 8.27 kilojoules per mole of CO.